Hey everybody, Mr. Field here, and today we're back with another quick little video, little mini lesson on how we can actually evaluate using a calculator. So far we've been pretty much evaluating trig expressions using either our trig toolbox, using the unit circle, or simply from memorization techniques. But now we encounter situations where these answers aren't going to be nice, pretty whole number answers or exact answers like root 3 over 2, root 3 over 3, or 1/2, etc. So we're going to end up getting some decimal values. So notice in this case we have 217 degrees, or 0.4 degrees. And notice this is not one of our special angles that we've been encountering, like 30, 60, 90, pi over 2, pi over 3, pi over 6, pi over 4. So we're simply just going to have to use our calculator to answer this question. So without further ado, let's do it. So step one, I want to make sure I'm in the right mode. Since I'm given the question in degrees for letter A, I want to make sure that I want to be in degree mode, which looks like I am. So all I should have to do is type in the sine of 217.4 degrees, and it should spit out my decimal answer. And remember, sine and cosine should never be more than 1, because again, in the unit circle, the radius or hypotenuse length is always 1, and the hypotenuse is, well, the longest side. So it looks like we're going to have negative 0.607 approximately as our answer. And as it said, round to the nearest 3 decimal places, so negative 0.607 would be our answer. Now, for a question like letter C, and I'm going to have you finish the rest of these in just a moment, notice we're given the problem in radians. So we have to make sure that we are in radian mode in our calculator to get the correct answer. So again, we're going to type this in 15 pi over 17 radians, and it should spit out a decimal answer for us. We're going to round to the nearest 3 decimal places. So again, I'm going to have to go back to the mode, switch to radians, and then I'm going to go back and actually type this in. So we want the tangent. I'm going to go alpha y equals so I can get my fraction going on. We're going to have 15. We're going to do second, and then a little arrow up there to get pi. I'm going to arrow down over 17. Let me arrow over and close that parentheses before I hit enter. So tangent of 15 pi over 17 looks to be about negative 0.387. The 4 doesn't tell us to round up, so we're going to say negative 0.387. And that's our answer. So the first section is hopefully relatively straightforward. I would suggest on a quiz, if you had problems like this, I would do all of the degree problems first and then all of the radian problems, so you're not switching back and forth like a maniac, left and right, between degree and radian mode on your calculator. Just a suggestion. All right? So let's keep cruising. Just before we jump into the next part, I want to just remind you, first and foremost, we know math is a language, and we want to know how to read it. When I see something like this, the sine of theta equals 6 over 13, that tells me that there's one thing that I don't know, and that's the angle. So remember, we're dealing with right triangle trigonometry. We know, for instance, sine is opposite over hypotenuse. So we could go as far as to draw a triangle, and let's say maybe this is theta, so the hypotenuse is 13, and we know that the opposite side would be 6. So really the only thing we don't know is the adjacent side. But in this case, that's not actually what it's asking for. It's actually wondering, hey, like, what's the angle? And we've actually done this before. You can see we use inverse sine in our calculator, or in this case, second sine for most of your calculators, to tell us what actually is that angle. So it looks like when we plug it in, get about 27.48. Let's just confirm on our calculator. So we're going to say, okay, we're going to say second sine, and then we're going to do 6 divided by 13, close parentheses, hit enter, and looks like, uh-oh, I made a big mistake, because guess what? I'm not in the right mode. That calculator assumed that that was in degrees, but it was really in radians. So let's try that again. A little happy accident there. Second sine, because notice I got a strange answer. That would not be a good answer for an angle measurement. Anyway, so sine to the negative first power, we're going to type in 6 divided by 13 one more time, and like it got, I think we get 27.48. Now, this could be a chance where your teacher might ask you to convert to degrees, minutes, and seconds, but you're welcome. I am not going to do that. We're simply just going to round it to the first decimal place, and looks like we ended up with 27.5 degrees. However, we have to remember there's a little bit of a problem, because now we are in the coordinate plane, my friends. So 27.5 degrees would be somewhere around here. All right. However, remember the trig function was sine. Sine refers to y. And considering this is a positive 6 over a positive 13, we have to ask ourselves, well, where is sine positive? Well, it's not only positive in quadrant 1, creating this triangle with a 27.5 degree angle, but it would also be positive in quadrant 2 with this triangle being a 27.5 degree reference angle. right? Remember, in the unit circle, these are mirror images of each other. So really the question is, well, if this is a 27.5 degree angle right here, 27.5, how much rotation is that? Well, really what we're saying is, what's the difference between here and here? And how do we figure that out? Well, we got to use the reference angle. So essentially, you could sit here and count, but the fast way is to just take 180 degrees, which is that line right there, right? And we're going to subtract the 27.5 degrees, and that should tell us whatever's left over, remember, because this is going to end up making 180 degrees, or a semicircle. That should tell us exactly how many degrees our second potential answer is. Remember, we're in the coordinate plane, so sine could be positive in more than just one location. Since it didn't tell us what quadrant it's in, we have to assume that there's more than one option and figure it out for ourselves. So the answer for quadrant 1 was 27.5 degrees. Again, here's a little chart on the right here that's going to teach you or kind of remind you what you should do. Notice the reference angle in quadrant 2, what we do is just take 180 and subtract whatever that number is. Notice they did that right here to get 152.5 degrees. That's another potential answer for where sine could be a positive 6 over 13, that angle. Then, of course, the other ones, right? If you end up with your terminal side part being in quadrant 3, you would simply take 180 and add that reference angle, and then of course 360 and subtract if you end up in quadrant 4 when you're doing problems like this. So use this as a little guide, little reference for your reference angles when you're trying to determine what the second answer potentially could be in these problems. Now, the other thing here is you might also encounter it down here in radians. Just notice instead of 360, it would be 2 pi minus. Instead of 180, it would be pi plus or pi minus, depending on what quadrant you're in, to figure out what the other potential answer just might be. So let's give that a try with one of these down here. So for instance, as we're solving for theta, we want to find the angle between 0 and 2 pi, or 1 rotation. Now, another little tip that it says here is when solving, what we're going to do is just drop the negative sign right off the bat. And what that's going to do is it's going to give you an answer in the first quadrant. And then from there, we can use our deductive reasoning skills to determine what quadrant we should actually really be in. Because remember, let's go back to the beginning. Sine is y. Now, our answer is negative. So where is sine? Wow, that's a bad y. Where is sine going to be negative? Well, we know our answer is going to have to be either quadrant 4 or quadrant 3. It's got to be one of those two. But what we're going to do is act like that negative's there just so we can find our reference angle, and then we can use the little trick from above to determine what our actual answers are. So let's check it out. So then we wonder, where is sine or y positive, and where does it get us a value of 0.499? Now remember, that decimal version is just the same thing as one of these problems. If I was to take 6 divided by 13, it would give me a decimal. They're just not giving us the fraction in this time. They're giving us the decimal. Hopefully that makes sense, right? So let's check it out. Let's bring up my calculator. So again, we're going to drop the negative, act like it's not there for a moment. And we're just going to say, hey, what is the... one sec. Pull up my calculator there. So here's the thing. In order to figure this out, let's just say we did it in degrees first, just to make it easier. But then we'll do it in radians. So we're going to hit second sine, and again, we're going to act like that negative's not there, 0.499. And that should give us a reference angle in the first quadrant. Looks like about almost 30 degrees. So we could round up to 30 based on 29.9. So just to use this little toolbox from the top right corner. So essentially, we have a 30-degree angle in quadrant 1, which in quadrant 2, we would take 180, remember 180, and subtract our reference angle, and that would get us a 150-degree angle in quadrant 2. So if sine was positive, right, like we have now, it could be 30 or 150 degrees. They would be our potential answers. However, we know it's going to be negative, so we're looking for the reference angle here. So we're going to take 360 in this quadrant, quadrant 4, and minus 30. So you should get 330 degrees. That would be your potential triangle in the fourth quadrant. And then over here, we would take 180 and we're going to add 30 to get 210. So it could be either 330 degrees or 210 as our potential answers for this problem between 0 and 2 pi. However, it did say 0 and 2 pi, not 0 and 360, so we really should do this in radians. So we're doing the exact same thing. We know 30 is really pi over 6. So we're going to take 2 pi and subtract pi over 6. Now, you could also do this considering we rounded, in decimal form as well. So we could take 2 pi and subtract pi over 6. Remember, 2 pi should be 12 pi over 6 minus 1 pi over 6. So we should get 11 pi over 6 as a potential answer. Oops, in radians. And then over here, if we take 180 degrees, which is pi, and subtract pi over 6, well, pi is also known as, should be, what, 6 pi over 6? It's half the circle. Minus 1 pi over 6. So you should get 5 pi over 6 as a potential answer in exact radians. But technically, we really didn't need to do exact because, well, it didn't give us exact. I did round 29.93 up to a perfect 30. So if it was 30, this would be the exact answer. But let's assume it's not perfect. And let's actually do this in decimal form. So let's go to our calculator. Let's make sure, really important, we're going to change the mode. We're going to go back down to radians. We're going to say, okay, let's do this in radian mode. So we're going to do the second sign of 0.499. Again, just drop in the negative so we get our reference angle in quadrant 1. So about 0.522. So going back to the problem at hand, we're going to take that 0.522. We realize, by the way, we have to be in quadrants 3 and 4. Why is that? Well, because our sign was negative, and that means y is negative. So we know we're hanging out in quadrant 3 and quadrant 4. We need an appropriate answer for each. So we're going to take 2 pi, also known as 6.28, and then we're going to subtract that 0.522. Again, I'm just using this little chart up here. When you're looking for a reference angle in quadrant 4, you take 360, or in this case 2 pi, and subtract the reference angle. And then for quadrant 3, we're going to take 180, or in this case pi, 3.14, and we're going to add 0.522. And that should get both of our answers in decimal form. So let's try it. Let's do 3.14 plus 0.522. Looks like 3.66. And we could do 2 pi, which is 6.28 minus 0.522. 5.76 approximately. And there would be our two answers in decimal form. So interesting questions. All right. Last couple, I'm just going to do a quick little preview because I'm running out of time here. Once we're done with expressions, technically we were just solving equations because it has an equal sign. Now this is the same thing, just it looks like a little bit more work. All right. So obviously I gave you some hints here. There's definitely different types of equations we can solve. The first one involves the GCF, or greatest common factor. So when we have a problem like this, right off the bat, notice it's equal to 0. I'm thinking, well, both of these terms have a tangent in it, and just like in algebra 1 and 2 when you were factoring, we can factor out a common factor, which in this case would be tangent. Each of them has at least one tangent theta. So if I divide away a tangent theta, I'm going to be left with sine squared theta minus 1, because tangent divided by tangent is 1, equals 0. Now, just like before, if I had something like x times 2x minus 1 equals 0, well, we would use the ZPP, or the zero product property, to investigate, hey, each of these individual factors could end up being equal to 0. So x could equal 0, and 2x minus 1 could equal 0. Sorry, looks like a plus. So I would add 1 to get 2x equals 1, divided by 2, x is 1/2. That's one answer. And of course, this one over here I didn't have to solve. Well, we're going to do the exact same thing, except now we're doing it with trig. So I factored out the GCF, and now I'm going to set them both equal. So it says, hey, tangent of theta equals 0, or sine squared theta minus 1 equals 0. So essentially, we're just going to be looking to see what angle, what theta, where is tangent equal to 0? And I'm thinking that's going to be at the quadrants. So again, we've got 1, 0, negative 1, 0, 0, 1, and 0, negative 1. So tangent should be 0. Remember, tangent is y over x in terms of x, y, r. So it should be 0 when we have 180 degrees, 0 divided by negative 1, or here at 360 slash 0, 0 divided by positive 1, that's when we get a tangent of 0. Now all we have to do is add 1, sine squared theta equals 1, square root, the sine of theta equals plus or minus 1, and investigate that. I hope this video was helpful. Take care.